We just need to find the sum between 1 and 100. Remember, to find the sum using arithmetic sequences, so this only works for if it's plus 2, plus 2, plus 2, or plus 3, minus whatever. All you need to do is find your first term. My first term is 1. You need to find your last term. I'll just call it a sub n for right now, and that equals 100. And then you have to find out how many terms you have. I'll let n stand for how many terms I have. I actually have 100 of them because you have 100 digits, you have 100 terms. All right, then we just plug it into our formula. It goes with s sub 100. So that says add all those 100 terms together. It's just going to be the 100 terms divided by 2 times 1 plus 100. Well, that's just 101 times 50, which is going to equal 50. And then we're done. All right, what questions do we have on the homework? So no one has a question. Last one? I know it's nice of me not to put the answer on the last one, except for that was very nice of me. All right. Let's go through it. Once I go through it, you'll see it was probably one of the easier questions. But once I go through it.
Yeah, because it's like you gave us, like, I can't find anything.
Yes.
Well, I gave you, so we have an English teacher who told her students that if they read 2n plus 1 pages of a long novel on the nth day of October. So let's say we're talking about the first day of October. So my first day of October, that's going to be my a sub 1. That's the first day I have to do a reading. Well, that means my n equals 1. So we're going to do 2 times 1 plus 1 is going to be 2 times 1 is 2 plus 1 is 3. The second day of October, I am now going to put a 2 in for that n. So we'll have 2 times 2 plus 1 is going to equal 5. On the third day, we're going to do 2 times 3 plus 1 is going to be 6 plus 1 is going to be 7. Right here, I'm going to recognize this is an arithmetic sequence. It is plus 2, plus 2. And if I kept going, October has 31 days, so on the 31st day, we'd have 2 times 31.
But who wants to read on Halloween?
Right? It's those mean English teachers that are the problem. Okay, so we have 62 plus 1 equals 63. It is arithmetic. I know my first term. I know my last term. So if it's arithmetic, I just write down my first term. My first term was 3 pages. My last day I have to read 63. That's 3. 63 pages. And the number of days where I have to read is going to be 31. Well, that's everything I need to come up with my sum, because my sum of all 31 days is going to equal the 31 divided by 2 times the first day readings plus the last day readings. And if you plug that in your calculator, you're going to come up with not 63, but you're going to come up with 1,023.
Yeah, because it's 3 plus 63, not 3 plus 61.
Gotcha. Oh, see, 3 plus 60. I see where that 3 was that you're talking about. 63. I thought you were saying the sum equaled 63. I'm like, no. Yeah, it should be 3 plus 63 because my last day was 63. And it comes out to 1023. It also asks for the average. You just divide that by 31 and you have your average. Yes?
Okay, I feel like this is confusing because it says that many pages on the nth day, but then it says what is the, oh wait, no, on the nth day and then for each day. Because I feel like for nth day they read a certain amount, but then it says for each day, so it sounds like they're reading the same amount each day.
Oh, okay, no. They're just saying on the first day they read 2 times 1 plus, and they have to read each day of October.
Okay.
That's what it's trying to say, that they don't just stop on the 15th. They're like, nailed it, got the full thing done. Yeah.
When I first saw the answer on the
Did you think I didn't know how to use commas?
I thought
Yes.
I thought that it was like 10. It was like 100,000 pages. And it was like, what did I do wrong?
Because on my answer key I actually wrote.
Like, a different answer was like 10,000.
I wrote. Which looks like, I mean, the answer was 1,023 and 33 was the average, but it definitely looks like I don't know how to use a comma placement. Yeah.
Can we move on?
Yeah, absolutely we can.
For 75, why did you put the difference as 12 and not...
I should have put negative 12. I should have put negative 12, and I would have caught it if I used it, but you really don't need that.
Does it not make a difference?
It doesn't, because I didn't actually use the formula. So let's talk about... So I did make the correction. I know exactly what you're talking about. At one point, I had this as a positive 12, right? And I actually used the positive 12 in here. So this was completely the wrong formula. It would not have helped me at all. But I actually didn't use the formula. I actually just used straight up math, where I was just like, okay, the first one has 9 rows times 12. The next one has 8 times 12, 7 times 12. And I know the very last one has to be 1 times 12. I knew what that equaled. Remember, to come up with my sum, I just need my first term, how many terms we have, and the last term. Well, I have the first term was 108. Through just multiplying 1 by 12, I came up with the last term. And to get how many we have, well, I went 9, 8, 7, 6, 5, 4, 3, 2, 1. So my n was actually 9. So I actually didn't use this formula at all. I would have caught that if I used it, but I didn't use it, so I didn't catch that I made that mistake in there. The answer is correct. It is 540 cans. Okay. The only reason why you use that formula is to get your maybe your n value by plugging 12 in here, and your n would come up. But it's such an easy thing to calculate that I just didn't actually use the formula. Is that good? Yeah. I apologize for it, because that's a big mistake. I should have caught that. Especially because I have a mistake up there, but the answer is right, where it makes you feel like, wait, what is he doing to get the right answer? Answer was right. That formula was wrong. I just didn't use the formula. All right, Aaron.
For 55, why does n equal 13?
For 55. All right, n is going to equal 13. Let's do the...
Yeah, I thought it was 12.
Yeah, me too.
Let's talk about why it's not 12. Let's do that. Let's do that. Why is it not 12? Well, let's look at it this way. Let's start from the basics. What if that was n equals 1? How many terms are there?
15.
Okay, there's 15. What if n was 2 then? 14. What if n was 3? So if you ever get stuck, here's the math behind it. Here's the math behind it. You can't just go 15 minus 3. Like when this is 1. When this is 1, you can't do 15 minus 1 gives you 14 terms, because you were forgetting to count 1. The difference between 1 and 15 is 14, but you have to add 1 back in there because you're actually using your first term. So if you want to mathematically do this, it has to be 15 minus 1 plus 1. So 15 minus 3 plus 1 would give me my 13 terms. If all else fails, if the earth is shattering and you can't do this, you're not 100% sure, just do this. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 13 terms. That's
I got confused.
when all else fails, just ask yourself how many times you plugged it in. Yes. Adios.
She's like, I'm done with this.
Yeah.
one.
Yeah.
For 61.
She doesn't even have to leave. Okay, 61. I'm tracking.
Why is n 249? Not 248. Is it the same thing as this? That's the question we just.
Yeah, so what I did kind of in my head, you could come up with your regular formula. Like we could come up with an explicit formula and actually figure out how many we have in here. But what I was looking at is, and I think you're forgetting to count 0, maybe?
Oh. Yeah, because I counted like 10
Yeah.
plus. Oh, okay.
Yep, you're forgetting to count 0 because we are going to put 0 in there. That's where that 249 comes in. So make sure you take care of that 0. Because I could easily see that being 248 because you forget about the 0 because you're just like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Take care of that one. There's 238 on that one. That's 248. Done. But 0 never got counted into either one of those. And don't forget to don't double count 0 either. Don't go 0 through 10 is 11, 0 through 238 is 239, and accidentally count it twice. So that's a good one to mess up on because on the test you'll be like, okay, I always account for 0. Yeah. Other questions? Those are great questions. I like that they're actually specific, not like, I don't get any of it. I like more specific questions because that makes you feel like you attempted it and you semi-understood it versus I have no idea how to start it. But are there any questions? Even if they are, I don't know how to start it, I'm okay answering them. I just really like when you have a specific question.
What are we supposed to put in the name?
What? Oh, gotcha. All right. If there's no other questions, let's go ahead and do this lesson. We have so far been talking specifically or most about arithmetic sequences where you just keep adding a common difference over and over and over. That common difference could be negative. It could be a fraction as long as it's adding or subtracting that same thing over and over. A geometric sequence is different. It's still a sequence, but instead of having a common difference, we're going to have something called a common ratio. Now, the difference between a common... Whoa. Ration? I don't know if that N popped up there. The difference between a common ratio and a common difference. There's a ration.
No, I didn't.
No. Common difference is you're adding or subtracting. Ratio means you are multiplying. You could think of it as multiplying or dividing, but we're always going to multiply. If you have to divide, you're just going to multiply by a fraction. So we're always going to multiply. You're going to ask yourself, what do I have to multiply each number to get to the next step? Well, if we divide everything, we come up with our common ratio, blah, 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 blah. Let's go right to our examples because it basically is a common difference, but now we're going to use multiplication. So we're going to look at that 1, 2, 4, 8. And what we're going to do is, well, first of all, it wouldn't be arithmetic. Arithmetic, if I was checking it, would be +1, +2, +4. So that doesn't work. It's not arithmetic. So once I know it's not arithmetic, I'm going to ask myself, is there a number I can multiply instead of add to each one to get to the next term? So to get from 1 to 2, I'm thinking, well, if I just multiply by 2, I can get there. To get from 2 to 4, I can multiply by 2. And finally, to get to 4 to 8, I can multiply by 2. So that is, in fact, geometric. And I'm going to write something after this. It's not too critical for this one because it was pretty easy to see it was time 2. We're going to let R stand for our common ratio. This is the easiest way to get your common ratio, especially if like decimals, weird fractions, or something you just can't think about. Is there something to multiply? To get your common ratio, what I'm going to do is I'm going to take my second term and I'm going to divide it. I'm going to take my second term, divide it by my first one. In this example, that would be 2 divided by 1, which equals 2, but we already knew that because it was pretty obvious. Our next one is obviously not arithmetic because that would be +6 on the bottom, +24, and then that doesn't work. So it must have some kind of common ratio. Yes? It is going to be 1/4, but let's pretend like we didn't see that. Let's pretend like we didn't see that. Yeah, let's pretend like we can't figure out 2 times 4 equals 8 and 8 times 4 equals 32. So I'm pretending like I didn't know that. So I'm just going to take my second term, divide it by my first term, which will come out to 1/4. And it has nothing to do with being dumb either. What happens on a test? When our brain just doesn't work and I want just a straight thing that's going to give me the answer, this is your thing to get you a straight answer to make sure that you have it correct. So it is multiplying by 1/4. So if I do 1/2 times 1/4, I get 1/8. 1/8 times 1/4 equals 1/32. 1/32 times 1/4 equals 1/28. This is, in fact, geometric. So a lot of times if I'm not sure if something's geometric, I know for a fact it's not arithmetic, but it has these weird fractions or weird decimals, and I'm just not sure if I'm multiplying. I'm going to find a common ratio, and I'm going to see if it works for everything. Yes?
On the test, are you going to put them in the same section, or are you going to split the geometric and the arithmetic?
Oh, I'd probably put everything together where I'm said decide whether it's arithmetic, geometric, or neither. If it's arithmetic or geometric, come up with equation. If not, just put can't. Right, chicken nugget. Okay. Recursive formula, yeah.
How did you come up with 1 over 9 over 1?
1 over 9 over 100. Where am I looking?
It's an 8.
Oh, it's an 8 over 1 over 2. So all I did is I took this 1/8 and threw it here. Took this 1/2, threw it down there. You divide it, you come up with your common ratio. It's pretty quick. You might kind of laugh and say, well, it looked pretty easy. It was 1 over 4. But when you're doing a whole bunch of these in a row, sometimes it gets harder and harder to see the common ratio. Sometimes it's just easier to divide and just get out of the way and not stress your brain out with coming up with the pattern. Okay, recursive formula. Our recursive formula for our geometric sequence is going to be the term I want is going to, did I put the R before? What did I do in the other class? I usually put the R before, but I just want to keep it all the same. Yes, I did. So we're going to do R times the term before. In other words, you're multiplying each term by some number over and over and over. The explicit form. The explicit form. And don't forget about this with recursive. A sub 1 equals some number. Whenever you're doing recursive, you have to list your first term. For explicit, that is going to be A sub n equals your first term. So that's going to be my first term. Plus C, no. Times your common ratio. To the n minus 1. So you actually have nothing you need to figure out. You just need your first term, your common ratio. There is no C where you have to do your first term minus your common ratio or something. It is just plug in your first term, plug in your common ratio, and move on from there. All right, let's move on to some examples. So this one says, list your first 4 terms. I want to stop there for a second. Well, you didn't have to, but I'm looking at this 3. I'm looking at this 3. And that 3 just has a power to the n to it. It's okay if it's to the power of n, n minus 1, n minus 2, something, as long as it's just n or something. That 3... maybe I should underline it so it doesn't look like. That 3 is actually my common ratio. My R is going to equal 3. And I'm not expecting you to recognize it right away. In fact, maybe you want to do your terms just to make sure it is 3. So let's do the first 4 terms looking at that. So my first term would be 3 to the first, which equals 3. My second term would be 3 squared, which is 9. Well, so far that's holding up because this was just times 3. Hopefully this pattern is going to be that this is 37. Well, it'll be 3 cubed, which does equal 27. So once again, that pattern holds, and it's times 3. And our last one will just be times 3 as well. So my A sub 4 is going to equal 3 times 27, so that's 60 plus 21 gives me 81. My next one is in the exact form as our explicit form up here, where it says it's first term times the common ratio to the n minus 1. 1 second, I want to get through this real quick. So that means this 100 is my first term. And this 1/2 is going to be my ratio, and that's because, like I said, we have to the n minus 1. Yes?
I don't get how the last one How do you just get A1 equals 3 to the first?
Because I plugged a 1 into both ends. Because my first term would be 1. 1 takes the place of this n, so 1 has to take the place of this n.
Okay.
And then 2 would have to be, well, 2 took the place of this n, so 2 has to take the place of this n. Both those n's have to be the same on the other side of the equal sign.
Or something.
Yeah. All right, so I actually know my first term should be 100, and my common ratio should be 1/2. Let's check to see if that's true. So when I plug a 1 in for my n, for my first term, we are going to have 100 times 1 over 2 to the 1 minus 1. Well, 1 minus 1 is 0. Anything to the 0th power is 1, so it's actually 100 times 1, which just equals 100. So that is my first term is 100. My second term would be 100 times 1/2 to the 2 minus 1 power. 2 minus 1 is to the first power. 1/2 to the first power is 1/2. 100 times 1/2 is 50. So that is, in fact, let me get this going. That is, in fact, times 1/2, like we thought. And once I know the pattern, it makes it pretty easy because I don't even have to write this stuff out. I can just immediately go to the fact that this should be 25. I mean, we can check it. 100 to the 1/2, 3 minus 1. Well, that's going to be 1/2 squared, which is 1/4. 1/4 of 100 is 25. So it is times 1/2. And I'm just going to use the times 1/2 to get my last one. So my a sub 4 is just going to be 1/2 of 25, which is going to be 12.5. So this is just easier to come up with that pattern rather than having to plug it in and just do on your calculator or divide by 2, divide by 2, divide by 2, divide by 2. It'll speed things up a bit. Questions? Okay. Then moving on. So it says write the formula for the general term of each geometric sequence. It's kind of like arithmetic sequences. When I want a general form or an explicit form, I always want to find my first term and my common ratio. Those are the two things I need. I need the first term and the common ratio. So my first term is going to be 0.3. My common ratio is going to be, take that second term, divide it by that first term, or you could have just looked and said, well, that's 1 over 10. I am just multiplying by 1/10. Maybe I'll move that down and write underneath it that this must be times 1/10. Check here, this would be times 1/10. So yeah, in fact, it is geometric. This one is times 1/10. It is geometric, 100% geometric, because I do multiply 1/10 and it gets every one of those steps. So now let's just write our formula. Our formula is a sub n is going to equal my first term times my common ratio to the n minus 1. Well, in this example, it's just going to be my first term is 0.3. My common ratio is 1/10, and we just raise that to the n minus 1th power. 1th. So that 1/10 told me it was geometric. Yes?
When do you know when to use recursive or when to use explicit?
When I ask you to. I don't think I asked you to use recursive on this one, but it's good to know because then you can pick it out. So if I give you, if I give you a recursive formula that looks like this and I say, is this geometric or arithmetic, it's good to recognize that this times a number is going to be geometric. Basically, this plus a number is going to be arithmetic.
Or just because it has an R?
Yes. I just mean if I actually put values in there. So if I did, so an example of this might be a sub n equals 3 times a sub n minus 1. That tells you it's arithmetic. Geometric would look something like this, where you'd have,
So I think that was geometry.
that was geometric, yep. This would be arithmetic. This one would be arithmetic if I just said plus 3, because what it's telling me is just keep adding 3 to the terms. What this is telling me is multiply each term by 3, which signifies geometric, adding signifies arithmetic. Yeah,
Why don't you say arithmetic as arithmetic?
because it's a different word.
Really?
Yeah,
But it's the exact same.
it is not the same spelling either.
Really?
It is spelled arithmetic.
How do you spell arithmetic?
We'll talk about spelling in a second. Let's get through the lesson.
Good question, though.
Do you agree?
We'll look at it if we have time. All right. So look at this one. It is alternating between positive and negative. You think you know what to do. Yeah, I don't. So if I have plus and minus, do not use negative 1 to the n or negative 1 to the n minus 1. Do not do it. In geometric sequences, you don't have to worry about positive and negatives. Everything will take care of itself. So on geometric sequences, just forget about it being negative and positive. It will take care of itself. And I'll show you. So we're going to do the exact same thing as we did on the other one. We're going to say, well, my first term equals 2. My common ratio is my second term, which would be negative 6, divided by 2. My common ratio is negative 3. Let's see if that satisfies this problem. Well, 2 times negative 3 does give me negative 6. Negative 6 times negative 3, I should put those in parentheses, times a negative 3 does equal 18. And finally, positive 18 times a negative 3 does equal negative 54. I do not have to worry about that negative 1 to the n or negative 1 to the n minus 1. I'm just going to treat this as any other geometric sequence and go, okay, my formula is going to be a sub n equals my first term, which is 2, times my common ratio, which is negative 3 to the n minus 1, and I am done. So the only time we have to even think about adding these on is arithmetic sequences. So arithmetic, you have to think about the negative 1 to the n. In geometric, don't worry about it. It will take care of itself. All right, C.
You always write positive plus negative, and it looks like plus plus
Okay, C. If you tried to set this up as I always do my arithmetic check first. I check to see if it's arithmetic. It just makes sense. Because if you'd find the ratio, it'd be 8 over 6, and 8 over 6 times 8 doesn't give me 10. You should always check to see if it's arithmetic first, because this one is, in fact, arithmetic. Arithmetic. Different words. Different words.
I've literally thought about that so much.
Okay. All right. Anyway, so it's arithmetic, and so not geometric for right now.
For now. ...
No, it's not for now. I mean, we actually know how to solve this. Let's do it then.
No. We don't have to.
So it's not geometric, but we could come up with the arithmetic sequence, which would be a sub n equals our difference, which would be 2n, plus our first term minus our difference, which would be 4. There's your arithmetic formula.
Would you want us to solve it? Like if you said right for like, or can we just put not geometric?
You could put not. You have to read the directions.
Right.
if the directions specifically say, I forgot, write a formula for the general term of each geometric sequence, then you would just say I can't because it's not a geometric
Right.
sequence. But if I said
like
just write the
them.
explicit formula and I don't tell you which ones to look for, then you'd have to on that one. All right, our next one is going to be geometric, but let's check. So our first one is going to be 1/2. Our not our second term, but our common ratio is going to be 1/6 divided by 1/2. Keep, change, flip would turn that into 1/3. So that tells me that if I multiply 1/2 by 1/3, I should get 1/6 out, which I do. 1/3 times 1/6 does equal 1/18, and 1/3 times 18 will give me my 54. So it is geometric. And so we're going to write our formula, which is a sub n equals my first term, 1/2, times my common ratio, 1/3 to the n minus 1. Okay, moving on. So this one says b sub n equals -2 to the 3n. I can rewrite that because right now I don't know what the common ratio is. The common ratio only works when I have that fully simplified and I don't have a 3 in front of that n. Guys, make sure you pay attention. I can rewrite this as -2 to the 3rd to the n. Let me clear that up just a little bit. I just have to write kind of small. So I can rewrite this as -2 to the 3rd to the n. Well, -2 cubed is going to be -8 to the n. Only now that it's simplified, do I know my r equals that -8. That is my common ratio, is that -8. So don't fall into the trap of thinking it's just -2 every time. You have to simplify it. There can't be a number in front of the n. There cannot be a number in front of the n. But we didn't have to get that common ratio. I'm just doing it because in the future you'll have to just find the common ratio. We could just say, well, b sub 1 equals -2 to the 3 times 1, which would equal -8. And if I did my b sub 2, that would equal -2 times 3 second, which would be -2 to the 6th, which is going to be a positive 64. Which, if you notice, that is times -8. And if we keep going, my third term would be -2 to the 3 times 3, which will be -2 to the 9th, which is going to be a -512. And finally, b sub 4 is going to be -2 to the 3 times 4, so that would be -2 to the 12th, which is going to equal 4,096. And if you check all of these would all be times -8 times -8, so it is in fact geometric. All right, my next one, I already know it's geometric because it's -2 times the number. It matches that recursive one that you were bringing up. We're talking about it, so it's -2 times something, so I already know it's geometric. Let's just make sure. My first term is a sub 1 equals 1.25. My a sub 2 is going to equal a -2 times the term before it, which is 1.25, which is going to equal a -2.5. Well, to get from here to here, I had to multiply by a -2. So my next step is going to be a -2, hopefully. A sub 3 equals -2 times the term before it, which was -2.5, which does equal a +5. It did hold up to the -2, so that must mean a sub 4 is just going to equal a negative 10 because we would just do times negative 2. That is geometric. All right, our last one. I immediately know it's not geometric. It's in an explicit form, and it's not 3 to the n. 3 to the n would be geometric. 3 down here is going to tell me it is not geometric. So let's check it. So c sub 1 equals 3 times 1, which equals 3. C sub 2 equals 3 times 2, which equals 6. C sub 3 equals 3 times 3, which equals 9. And finally, C sub 4 equals 3 times 4, which does equal 12. If we look at it, it is an arithmetic sequence or arithmetic sequence. So here's the big problem with that. Arithmetic is a math. Arithmetic is a sequence.
What, how is it? Yeah, isn't it?
I was just thinking about this. It's the same spelling, but it's pronounced differently.
No, I thought arithmetic was an A. Arithmetic instead of the same.
It's the same.
Really?
You just have to know when you're talking about sequences, you're not talking about the class. You're not talking about the maths.
But they're both
Aspect of it.
math. What
No. One's a complete maths. Arithmetic is adding, I mean, it's a whole big thing by itself. You can actually have a arithmetic class. You're probably not going to have an arithmetic class.
That would be awesome.
Because it'd be a class just on arithmetic sequences, which would be the most